All right, so in a problem like this, again, the first thing you do is just draw what you know. Okay, so we have our XY coordinate plane here. We have two forces. One is 20 newtons, one is 10 newtons. When we have forces, these are our magnitudes. Just as a general rule of thumb in pre-calc problems. Then we have the degrees, the angles at which they are pulling. So the first one is pulling an object at 0 degrees with respect to the x-axis. Where is that?
On the x-axis.
It's just on the x-axis, right between quadrant 1 and 2. So here's my first vector. It's at an angle of 0 degrees and it has a magnitude of 20 newtons. The second one is a force of 10 newtons that has an angle of negative 30 degrees with respect to the x-axis. Where is that going to be for us? Okay, in quadrant 4, and I'm going to draw this one slightly shorter. Why? Because it's 10 newtons instead of 20 newtons. And I know that the angle in between these two right here is 30 degrees. It's negative 30 degrees because it's going into the fourth quadrant. So what we're going to do with these then is set up vectors for them in component form. So just reminding you of a formula that we did last time. To find component form using magnitude and direction, we did r times the cosine of theta, r times the sine of theta. So we're going to find two component forms. I'm going to kind of color code things here for you. What I'm going to call force 1, we are going to do its magnitude, which for our first force, what's the magnitude? 20 times the cosine of its angle. Well, that one was at what angle to the x-axis? 0. Then 20 times the sine of 0. That gives me, if I typed it in my calculator, I could get this back out. But if you also remember, at 0 degrees, the cosine is what? 1. And at 0 degrees, the sine is 0. So if I plugged those in, 20 times 1 gives me 20. 20 times 0 gives me 0. So that's component form for my first vector. I have to do the exact same thing to find component form for my second vector, what we're going to call force 2. Force 2, what's its magnitude? 10 times the cosine of what angle this time? Negative 30. 10 times the sine of negative 30. Now we can type this one into our calculators to get decimals to see where this one is. Making sure you are in degrees. This one, you should get something like 8.66 and negative 5, if I'm rounding to 2 decimal places. To find your total force, we add together force 1 and force 2. So in this case, we have component forms for each of them. We already know how to add two vectors together, right? What do? Add them together. Add together your x components. Add together your y components. This creates a new combined force vector for you that if you wanted to, you could graph it out. It asks us to find two things for this. Draw the resultant vector, which would be somewhere in the middle of here-ish. Find the magnitude and find the direction, which we haven't done yet. Okay. We should know how to find the magnitude of that vector. How do I do that?
A squared.
Square root of a squared plus b squared. Which in this case, in word problems, it's best if you just get a decimal for these, especially if you're plugging in decimals. There's no way I'm going to get a simplified radical on this one. So if I do the square root of 28.66 squared plus 5 squared, I get a force of about 29.09 newtons as my final magnitude. So far in this, we've done nothing with vectors that we haven't done before. Take the magnitude and direction, find component form, add together two of them to get your total force, and find the magnitude of that. The only thing we haven't done is direction. There's two ways to look at this. Okay, I'm going to draw this. I can give you the formula for it. The formula for it is the inverse tangent of the y of the component form divided by the x. However, some of you will understand it better if you see a picture of why that is. If you think on the coordinate plane, our resultant vector was 28.66 to the right and down -5. If I draw that, that creates for me a triangle with an angle right here. What sides from that angle do I have? Opposite and adjacent, right? If I have opposite and adjacent, which of my three trig functions do I set up? Tangent. So that's why it's set up like that, because y is the opposite and x is the adjacent. So you do the inverse tangent to find it. So using what we just had here, here's my x of my component, here's my y of my component. To find the angle, I'm going to do the inverse tangent of what over what? -5 over 28.66, and we're going to round to the nearest degree. This gives me approximately negative how many degrees? 10. Now, that should make sense conceptually to us. One was at 0 degrees. That was the bigger force. The other one was at -30 degrees. That was the smaller force. It'll be pulled closer to the larger one because that was the larger force. But it will be somewhere in between those two, logically speaking, for us. Now, there is something that gets funny with your tangent occasionally that we will talk about, because it's not always going to be the right angle. But other than that, it's pretty straightforward. Are we ready to try this again? All right, question 2 will be our second force question. Then we'll do 1 or 2 with planes. This time we have two forces with magnitudes of 400 pounds and 300 pounds. They act on an object at angles of 25 degrees and 70 degrees, respectively, with the x-axis. So let's draw our first vector. Our first vector has an angle of what? 25 degrees. So we're just estimating this. Here's my 25-degree angle-ish. And this one has a magnitude of 400 pounds. Our second force has an angle of what? 70, which is way closer to 90. And it's a little bit smaller with the magnitude of 300 pounds. All right, so using what we did on the last problem, what do we find first for each of our vectors? Component form. So for force 1, how do I find component form? 400 cosine 25, 400 sine 25. Okay. Then we'll set up the same thing for force 2. For component form for that, we're going to do what? 300 cosine of 70, 300 sine of 70. So take a minute, type those in your calculator. All right, so find your total force by adding them together. Then it asks us to find two things from that, direction and magnitude. So see if you can finish that out from there. When we discuss planes, ships, any of that with bearings, we have to think a little bit differently on this. We care less about the x and y axis and a little bit more about north, south, east, west according to the compass. Okay? So when we do that, just a kind of quick little drawing to show you how this works for us. Bearings, or they also call it heading or compass direction. Y'all should know your north, south, east, west. When you are given angles in terms of these, 0 degrees is north. And it goes the opposite direction of what we're used to, so it goes clockwise instead of counterclockwise. At least in the math world it does. So that's kind of how we need to think about that. 0 degrees is up at north. 90 degrees would be east. 180 degrees would be south, and so on. Okay? Now, some of these will tell you they're flying directly south, they're flying directly east, they're flying directly north, which makes life easy. A couple of things to talk about in vocabulary in terms of this as well. We have 2 things in these that you'll see, tailwind and headwind. These should be rather easy for us once we actually understand what they're talking about. Tailwind is directly behind the plane, going with the plane. It helps it. Headwind is going directly against the plane. So it's going to hurt its speed rather than help it. These are, you don't even really have to do vectors for them if you don't want to, but you can. In this case, they tell us our plane is flying south with an airspeed of 100 kilometers per hour. In the terms of these plane ones, the speed, these are going to be your magnitudes, the speed of the plane. So if our plane is flying directly south with a speed of 100 kilometers per hour, it tells us that it has a 25 kilometer per hour tailwind. Just because it's a tailwind doesn't mean the vector has to literally be drawn behind it. It can be in front of it, connected to it, along with it. It doesn't matter how you want to draw that. We frequently see those just starting at the origin and just showing it going alongside with it. The main thing for you to know with tailwinds, we said this helps the speed of the plane. So, of course, you could do vectors for this if you want to, but it's a complete waste of your time. Total speed of a plane, if the tailwind's going in the exact same direction of it, you simply add your speeds together. So the total speed now is 125 kilometers per hour, and that wouldn't change your direction at all because it's going directly with it. On the other hand, for something like Part B, if it's going the same direction at an airspeed of 100 kilometers per hour, but the 25 kilometer per hour headwind instead of tailwind, the way we would draw that, the plane's going south, this would be working against it, going the opposite direction. You can start it at 0, you can start it
That's weird.
you can start it at the end of this one going backwards. Really, for this, it doesn't matter as long as you know that a headwind hurts the speed of the plane. Therefore, my total speed would be what? 75 kilometers per hour. So if they ever talk about direct tailwinds or direct headwinds, that makes life very, very easy for you. Now, Part C, less so.
Oh no.
Okay. It's not actually that bad. You just kind of have to draw it out. So when I look at Part C, the first thing that we have to deal with is just where the plane is. So this is why I talked about the headings and bearings up there from north. This one says the plane has a heading of 130 degrees from north. So let's just count that out real quick. We said north is up here. 130 degrees from north means in the clockwise direction. So, and you don't have to draw this with me right now, from here to here is how many degrees? 90. How many more after that?
40.
Okay, another 40 degrees. So my plane is going to be in what quadrant?
Dos.
4.
4. Just kidding.
Okay, so my plane's going this direction. I can label one of 2 angles or both of them in here. I can say from here to here is 130 degrees total. I can also say from the x-axis down here is negative 40 degrees. Why am I going to need that negative 40 degrees? When I start typing things in my calculator, does my calculator talk from north?
No.
No. My calculator talks from the x-axis still. Okay, so you're still going to need those angles in there. Now, this one encounters a wind. Now, here's the deal for these that you have to read carefully. From the west. When it's from the west, what direction is it going? East. All right? So, when you draw this, you draw your vector going directly east. There's your wind. And it's 25 kilometers per hour. Whereas my plane is 100 kilometers per hour. Okay, so if it's from the west, it's going to the east. Now we're going to work this one the same way we worked the forces one. We have two vectors. We need two component forms. We're going to combine them to find total speed and go from there. So let's start with our plane. My plane, four component form, I need magnitude times the cosine of the angle, magnitude times the sine of the angle. What's my magnitude for my plane? 100. Cosine of what's my angle for my plane? Negative 40. I cannot use the heading or the bearing because it's from north. I got to use the angle with the x-axis when I type it in my calculator. So then I do 100 times the sine of negative 40 as well. Then I also have to do a vector for the wind. What's the magnitude for the wind? 25 cosine of what angle? 0. How do I know it's 0? It's directly on the x-axis, so I got to think about that in terms of my x-axis and coordinate plane there, and 25 times the sine at 0. Then we'll finish this up exactly the same way we did the other ones. Add them together to find total speed. We'll talk about the angle as soon as you're done finding that from your calculator, but go ahead and do that for just a second. On this, you do get negative 32 degrees as your angle. That is, however, not the correct answer in terms of bearings. Bearings are from north, right? So let's think about that. If this is negative 32 degrees this way, what would the angle be from north? Or how would you find the angle from north? 90 plus that 32. Because we're actually looking for what is this whole angle there from north. So you got to think about 90 and 32 would give me a final angle of 122 degrees from north. So that's just a notation thing to remember in terms of plane things. But issues, problems?
If we like walk that far and then
That'd be like 1 point.
okay, so
It's not like the whole thing's wrong, no. All right, so homework is 349. 1 through all of them because, yes, I know, 1 through all. Because like 5 is super easy because there's like the headwind, tailwind ones that take 2 seconds and blah, blah, blah.